All right, let's see. Basically, we're going to do what we did in the last example, but formalize it with a step-by-step process. Again, I don't love step-by-step processes because I like to approach the problem more logically and try to figure it out. Like, what do we need? How do we get there? But some people really like step-by-step processes, so I'm going to try to include it because not everybody learns the same way. So, if we're trying to maximize revenue or profit, and we have data on demand and prices, just like the last example we did, example number 5, we're going to example 7 next. Then here's how we do it. Let's do the steps. I'm not going to talk about the steps yet. Let's look at this example and then we'll do each step. Company is planning to sell a new smart fitness device. Development is going to cost $700,000. Each product is going to cost 30 to manufacture. Okay, look, fixed cost, variable cost I'm seeing. Market research suggests if they sell the device for $100, they could sell 30,000. Every $10 they lower the price, they could sell 5,000 more. Oh, that's a demand equation. Assuming quantity demanded is linearly related to price, determine the price that will maximize profit. Okay. Step 1. Use the data provided to create a usually linear demand function, releasing price and quantity. So let P be price of this device. Not how you spell it. Device in dollars, and Q be quantity sold. So step 1 says find a relationship between these two things. It's usually going to be a line. And again, you can either solve for Q or solve for P. Doesn't matter. If it's going to be a line, Q will be B plus MX, just like we had before. If we need a linear relationship between these two things, this is what it's going to look like. Sorry, I said X. I meant P. Doesn't matter whether you solve for P or Q. All right, how do we find this line? Well, we need points. Because I have Q by itself, Q is going to be our output here. All right, so we're going to look for some points that have the form input P, output Q. So do we have some? Developing the product will cost 700,000. It's always going to be 700,000. That doesn't have to do with how much we're selling it for, how much we're doing. Each process is going to cost $30. Yeah, it's still talking about cost. We're looking for the relationship between demand and price. If we sell the device for $100, this looks promising. We can sell 30,000 items. Okay. So before, I let Q be in thousands. I want to show you what happens if Q is not in thousands. So let's say at a price of $100, we can sell 30,000 items. So we're going to have a lot of zeros now. Okay. We could let Q be in thousands. All right. So that's price and a quantity. We need another point to find the slope. If they lower the price by $10, they're going to sell 5,000 more. If they lower the price by $10 down to $90, they'll sell 5,000 more. And again, $80 would be 40,000, etc. We could use any of those points. All right, how do you do this? Well, you can use a slope formula. M is going to be, what are the outputs? The outputs are Q's. It'll be change in output over change in input, because inputs, how we have written it, inputs are P and outputs are Q. Doesn't have to be that way, but how we've written it, it's that way. Or you could use this to find the slope, right? We increase by 5,000 if we decrease price by $10. So the slope's negative is going to be negative 500. But you can use the formula if you want as well. So 35,000 minus 30,000 over 90 minus 100. Don't always put the bigger number first. Make sure it's second minus first on both. We'll get 5,000 divided by negative 10. or negative 500. Again, for demand, we should have a negative slope. As we increase the price, demand should drop. Increase the price from 90 to 100, demand drops 5,000. All right, so we're getting closer. Q is B plus M is negative 500 times P. Now we just need B, just like we did before. So what's P? Oh, P's our variable. What's M? Negative 500. What's B? We're solving for that. To choose a pair of P's and Q's. When P is 100, Q is 30,000. So notice in the last problem, right? I let our variable be in thousands because I said I didn't want to deal with a lot of zeros. Here, we're going to deal with a lot of zeros. But maybe you prefer zeros to fractions. 30,000 is B minus 500 with 2 extra zeros. That's 50,000. Add 50,000 to both sides, you're going to get 80,000. That's only just one way of finding the B value. There's another way, right? If every decrease of 10 increases by 5,000, then if we decreased by 100, our starting value when the input's 0, if we decrease by 100, should increase by 50,000. 80,000 now. So either way, we know that Q is B, just 80,000, minus 500 times P. Here you can really see the relationship between price and quantity. Every increase in price of $1 decreases the quantity by 500. That's what slope's all about. Every time price increases, quantity decreases by 500. If price increases by 10, quantity decreases by 5,000, etc. So that was our step 1. That was just step 1. Find a demand function, just like all the way back to chapter 1 or 2. Getting my chapters confused. We did that. That was step 1. We did it. Now let's do step 2. Create a revenue equation with price and quantity, and then do other things. What's the relationship between price and quantity for revenue? Well, it doesn't say anything special about revenue. It just, okay, so revenue is just price times how many we're selling. We sell 5 devices for $7. That's $35 revenue. Revenue is how much we're taking in. All right, then substitute the demand equation. So your revenue equation is just in terms of quantity or price, just in terms of one variable. Okay, so it doesn't matter that we're getting rid of quantity. So revenue is P times Q, and we know Q is 80,000 minus 500 times P. We've got a quadratic revenue function. We could distribute and put it, we could do a couple of steps, distribute, put it in standard form, just like we did before. We'll get negative 500 P squared plus 80,000 P is our revenue function in standard form. That's step 2. Step 3, if you need to maximize profit, and we do, if you need to maximize profit, create a profit equation. Profit is revenue minus cost. We know the revenue. We haven't mentioned cost yet. Let's find that. We need cost. Okay. The cost. So developing the cost is 700 grand. Each product is also going to cost 30 to manufacture. So fixed cost, 700,000. And an additional $30 for every quantity produced. Now we got to take revenue, subtract cost. That'll be our profit. Profit is revenue, which is negative 500p squared, plus 80,000p, minus the whole cost equation. So distribute that negative. 700,000 plus 30q. Let's simplify our profit equation. We get negative 500p squared. We get a oh no. Okay, that's why the notes told you to solve for quantity, or to only get quantity, because we want a function of only one variable. So they actually did want you to set this linear equation up and solve for p. Doesn't really matter, but we do have an extra step here. So right, this is our cost equation. So what is this really? That's 700,000 plus 30 times q. And q is 80,000 minus 500p. That's really what we're subtracting out here. Subtracting out that 700,000 plus 30 times that. Let's distribute that right here. That's going to be 240,000. And then distribute that is going to be 500 times 30. 500 times 30 is 15,000, right? Yeah, okay. So you'll have an easier time with this. I said it didn't matter, and they're both right. Easier if you have P is equal to B plus MQ. All right, both work, but you won't have to do this extra step if you do it the other way. All right, sorry about that. What we have here is plus 80,000p. We can do things once. Combine like terms. We're adding an 80,000p. And then we're adding another, because we're subtracting a negative, adding another 15,000p. Now we have 95,000p. And then the constants are just going to be the 700k plus the 240k. That's 940k. Out at the end. There's a lot of zeros for me. This is our profit equation. A little bit more complicated than it needed to be, because I did solve for Q instead of P. But they both work. And this is a great opportunity to show you what happens if you solve for the other variable. Find the vertex of this function, right? We want to maximize this. We want to maximize this profit. It's got a negative a value, right? A is the coefficient of the squared term. It's negative 500. B is the coefficient of the linear term, 95,000. C is the constant, negative 940k. So that's our profit function's a downward facing parabola. The maximum going to be at the vertex. And the vertex is when our input variable, in this case for me it's price, is negative b over 2a. I have room on the next page? Not really. That'll be negative 95,000 over double negative 500. So we're dividing by negative 1,000. It's 95. All right, that's the price. What do we want to do? Determine the price that'll maximize profit. And that's why I solved for Q. I thought I'd be saving us steps. So a price of $95 per item maximizes our profit. And that's our answer. Great. So if you did do it this red way, solve for P, you'd get a Q value down here. Once you found your Q value, then you're going to go to step 5 and define the price. Okay. Let's specify up here that it's probably best. Solve for P. P equals B plus MQ. That's going to be easier for you guys. Both ways work, but this is usually going to be easier. We'll try to make it easier when possible. Let me know if you have questions about that one. And hopefully the step-by-step method helps you out a little bit. And enjoy the next one, where we do something a little easier.